Hi everyone, I hope this finds you doing well. I want to show some enhancements to Illuminated Cloud around Apex code generation. Now, Illuminated Cloud has had a lot of features for Apex code generation in the form of, from as simple as code completion to live templates to template-based file creation to postfix code completion, overriding and implementing methods, those types of things. Now, this is going to be somewhat similar, probably more similar to the last one, overriding and implementing methods, but it is actually the most requested feature. The ability to generate some things that would normally be boilerplate, rote, just kind of annoying to have to do, but you still have to do them. Creation of constructors that properly initialize your member state, implementations of getters and setters to properly support encapsulation of fields versus, say, properties. Proper implementations of equals and hashCode based on your member state, customizing the string-based representation of your object via an override of toString, things like that. So why don't we go ahead and jump in. Now, the starting point here is going to be two classes that have a base and derived class relationship. So an individual, you can call it a person, but that would get confusing with Salesforce's person, has a few pieces of data. They have some government assigned ID number that's unique to them. They have a name, which could change. You can legally change your name. A date of birth, that can't change. You can fib about your date of birth and your age, but basically you were born on a particular day. And then an account that would be like a Salesforce representation of more information about this individual. And then you can extend that to say, what is the employment state of this individual? Are they employed? If they're employed, what's the account of their employer in this org? It's contrived. Don't read too much into it. As we work through this, you'll see that it just supports the use cases I'm going to be showing. Now, the other thing I want to point out immediately is you'll see as I go through this, I'm going to be using keyboard shortcuts. You'll see the actual keystrokes that do the things I'm doing show up in a little banner at the bottom. Just a plugin I have installed. And it'll show both Mac and Windows/Linux key binding. So if you're wondering how I did something, how to do it as efficiently as possible, take a look at these keyboard shortcuts. All right, so with that, let's dive in. So with these classes, we have all private member data. And so we want to make it so that we can initialize that. And some of these are final. You can see they would be immutable upon being initialized. So we initialize them probably through the constructor. And we also provide external access to them through things like accessors. So let's go ahead and do that. I'm going to go ahead and use the generate menu, and I'm going to say generate a constructor, and we'll go ahead and say that we're going to generate everything. Let's say everything. Okay, so now it creates a constructor with all four of those pieces of data, and you can see that it includes assignment statements for those. So now these are properly initialized. Now we can see that there are a couple of issues here. We'll deal with them in turn. We can see that it's saying that name can be final. It's not really an issue. It's just kind of a hint about what's going on. Name can be final, and that's because it only sees it being initialized in the constructor. We don't ever see another assignment to it. Now, like I said, the name can be changed. So instead of making it final, we're not going to do that. Instead, we're going to generate accessors. So we can generate just read accessors, just write accessors, or both. So we'll go ahead and generate both, and we're going to choose all the fields. Now you notice it doesn't include in this list the property, and that's because accessors are effectively core to the notion of a property. You have a read accessor and a write accessor in the form of the get and set. So this is a read-only immutable property. It's not included in this list because getters and setters just don't make sense for it. They're superfluous. So I'm going to go ahead and generate for all three of these. I'm going to hit enter, and let's take a look at what happened. So we have a getter for ID number. Notice we don't have a setter. That's because it's an immutable property. If we created a setter and we set a value, that wouldn't compile. That wouldn't be valid. Even if it compiled, I can't remember how Salesforce does this. I know there's an omission. You would get a final exception when that assignment took place because it would already be assigned. Now, name is a mutable property, so you can see that we have both getters and setters for name, and then date of birth, as I mentioned earlier, is also immutable, so we only have a getter. Now, let's go to the other class. So we have an error, not just a warning, but an error or a tip. So it says there's no default constructor. In this case, think no arg constructor available in individual. There's no constructor in employed individual, only the default no arg constructor, and it would try to chain to the default no arg constructor in the base class, and it can't do that. So if you tried to save right now, if you tried to commit this to the server, you would get the same error, but Illuminated Cloud's telling you immediately, so we can deal with it kind of in real time. So we're going to create constructor matching super. Now, if there were multiple base class constructors, we'd get the opportunity to copy them down as well here. So we're going to go ahead and copy down the one constructor that's there, and you can see that it created you can call it an override, but basically it's a compatible constructor that's going to ensure that constructor chaining occurs. Now, we still have some yellow here, and that is that we haven't assigned values to our local member state, not the base class member state, but our local member state. We certainly want to do that. So we'll go ahead and say that we want to add constructor parameters. So this is, again, the context menu that comes up. And I'm going to hit enter, and I want to go ahead and assign for both of them. So you can choose one, both, or none. If you do none, it's going to tell you the constructor signature already exists. So I'm going to go ahead and say that I want to do this, and you can see that it's brought up a change signature dialog for this constructor, and it's added these with default values based on the data type. Now, I want to change the default value here to false because by default we're passing in an account of null, which means you're unemployed. And the other thing I want to do is retain the original signature where there's no employment status, basically the pass-through. And I want to have one that takes the local state and delegates. Okay, so let's look at what happened here. So the original signature is still here, but now it delegates to one that takes all of the information that's needed, and it changed to the base class constructor and initializes the local state. And so I'm going to make this a little bit neater. Here's another context action. Put parameters on separate lines. We'll go ahead and do this with each one of these. And we can see that that becomes a little bit more clear to read, especially with this limited horizontal real estate. Now we still have some yellow, and that is that it's saying that these have only been assigned. Same issue we had on the other side. We could make these final, but we do want, these are mutable properties. So we want to provide public access to them. So instead, I'm going to, again, generate getters and setters for these. And because they're mutable, we can see that we, for each property, we have a getter and we have a setter. So far, so good. No more errors, and the only warnings that are here have to do with things being unused. So let's look at some other generation capabilities. So we'll go back to the base class. I want to go ahead and generate equals and hashCode for this. Now, the reason these are paired together, if you're not familiar with this, is the equals and hashCode have a very tight relationship. And in fact, I'll show you in just a moment, I've added a static code analysis capability, a code inspection, that verifies that when one is implemented, the other is paired with it. So we'll go ahead and generate equals and hashCode. And it's important that the logic inside of these also be consistent. Not that they're paired, but they basically implement the same or similar logic. They use the same member data, and when member data is considered to be equivalent in equals, that they hash to the same hash code. So if you think about it, by the way, the reason is put something into a set. The way that set works is it's got a bunch of hash buckets for efficiency. And so it's going to use the hash code to find the right bucket. And within that bucket, many things can hash to the same value, hopefully smaller numbers. Within that bucket, it's going to find the exact matching member using equals. Okay, so that's kind of the way that works. If you say like contains, find the right bucket using hash code, find the right member using equals. So it's important that these be paired. Okay, that was a bit of an aside, but that's why this works the way that it does. So let's just go ahead and say for a moment that the ID number, name, and date of birth are important. The account isn't. So we'll go ahead and hit enter, and it's going to show the same subset of fields for hash code. And you could do a reduced subset, but again, you need to be careful to make sure that the logic is internally consistent. So we'll go ahead and hit next. And now it's asking which of these fields could potentially be non-null. Because that can simplify the implementation. Now, like I said, the ID number is a government assigned ID number in this. Let's say for a moment that like for an infant, it may not have been assigned yet, which is in conflict with what I said about it being immutable earlier. But for the sake of showing a better example, we'll go ahead and just say that these are always going to be non-null and that this is nullable. And we'll say create. And so it's implemented equals and hash code. And so let's just take a look at what it's done. If you're familiar with the way these get generated in Java, or if you followed suit doing the same type of thing in Apex, these are going to look really familiar. Minor differences due to some limitations in Apex. And not only that, but language differences. So first, if they're the exact same reference, notice the strict equality operator, then we're done. They're the same object. If the object passed can't be assigned to the same type as this object, they can't be equivalent. Now, normally you'd want to do strict class equivalence instead of, because individual could be a subclass, employed individual, and they may not be the same. You can't do that in Apex. It's the best we can get, and it ensures that we can do a type safe cast here. And then we're going to do a property-wise or field-wise equivalence check. Now, because ID number was set up to be null, it's basically saying if the left side is non-null, is it identical to the right side? Or if the right side's non-null, is it equivalent to the left side? Or if they're both null, are they both the same null value? So this basically is an equivalence check for something that can be null. And then the other ones we know are always going to be non-null, so we can immediately begin dereferencing them. And so you'll notice these are slightly different, and that is because this system.equals is going to use the same semantic check as the same semantics as a double equals check, and that for strings does a case insensitive comparison, equivalence comparison. And so that may be what you want. For a name, that's probably fine. For other things, it may not be. By default, it's going to generate this using string.equals instead of system.equals, so we get a stronger equivalence check. And then for date of birth, it can just use the system.equals because we know that it's non-null. And on hashCode, it's going to do something similar. If it's nullable, then we have to do a null check first. Otherwise, we can use system.hashCode, and then we're going to build up kind of the way that you would for building up a multi-value hashCode. So we have valid implementations of these. And if you wanted to regenerate these, you can. You can just say you've added or removed fields or properties, or you want to change the set that could be non-null, you can just do this, and it'll prompt you. Do you want to go ahead and delete the implementations that are there and run you back to the wizard? If you want to, that's the easiest way to kind of regenerate these and bring them up to date as you evolve the associated class. And we can generate a toString implementation. Now, this may not be as useful because one thing Apex does really well is its default implementation of toString does a great kind of string serialization of the state of that object. Now, if you want to maybe do a subset of the data, or you want to change the order of the data, or you want to provide more information, this is a great way to do it. So let's say that we wanted to include all of these. We can. Notice there's an option, use full class name. If the containing class was in a namespace or was an inner class, you may want to have the full class name in the serialized output. I'm going to go ahead and leave this the way that it is. And so you can see that it went ahead and created a nice little toString for us. Okay, so let's go do the same things over here and see how that works. So we'll go ahead and go to the derived class, and we're going to say implement equals and hashCode. So both of these, we'll go ahead and include both these in equals and hashCode. And both of them, so employed we'll say can be non-null. It's going to be non-null. Employer account can be null. So employed is always going to be true or false. Employer accounts could be null. So we're going to end up with this. Now, there's a couple of things that are worth pointing out here on both sides. First, there's a third check here. We talked about the first two. You can see now it's saying it's chaining because it sees that there's an explicit implementation of this in the base class. It's chaining the base class. So if the base class doesn't evaluate to equals, we can quit now. We don't have to do any local evaluation. Otherwise, do the same type of evaluation, property-wise, field-wise evaluation that we did on the other side. Same for hashCode. It's going to start with the super hashCode, and then it's going to basically build on top of that. Now over here, let's go ahead and do a toString real quick before we move over. So we'll go ahead and say toString, and we'll include both of these. And you can see that it included super.toString. Now, if we didn't want that, same thing with equals and hashCode, we can regenerate. So do we want to regenerate it? Yes. And we can see there's a configuration option for this action down here. And now we can say we don't want to include it, and we get a version that doesn't include it. I'm actually going to regenerate one more time because we're going to come back to this, and I'm going to show you that we do want to include it and what that looks like. So there we go with our toString. Now we have a couple of errors over here. What are our errors? Well, we're now overriding that, but we are not following the correct behavior in Apex, where if you have a class that's overridden, it has to be virtual or abstract. So we'll go ahead and use Illuminated Cloud's quick fixes for this to add virtual, add virtual, add virtual. And I think at this point, this is completely, let's see, this is green. We have never used there, things like that. And then the only things we have over here are never used. Let's see if we save, everything should be good to go. And it's saving both of these because I've been changing both of them. And so everything's saved just fine. So that's great. And so let's go to Anonymous Apex. And I've already set up a little Anonymous Apex script here so we can execute it. And we can see, and yes, I am that old. And so we can see here that this is our serialized output. And we can see that it says, okay, well, here's the information about employed individuals. So we'll start with the superclass information, which goes to about here. And that's showing information about the account. And then here we have our local properties, including the account. So that serializes nicely. Now, having said that, I mentioned previously that we'll go ahead and just say, we'll just get rid of these. and we'll see what the normal implementation is, so you can see why this is maybe the least useful, these code generation capabilities, if all you're going to do is implement what's already there. We can see it looks very, very similar. Order's a little bit different. It's kind of flattened out some of the S objects that are in here, but for the most part, you get the exact same information. So up to you as to whether you find this to be useful. But it's available if you want to customize the serialized output. Maybe that is a little bit nicer. Okay, so that's it. So those are the code generation capabilities right now after 2 phases. The third phase that I'm looking at next is generation of, for production Apex classes, test Apex classes, and stubbing of test Apex methods for testable Apex methods in the production class. So obviously things that are private that don't have test visible, things like that would not be available. And then you could catch up methods as you add them in the production class. You could go and say, kind of fill in the gaps on your test class. Now, the reason that I may not do that is we're right on the cusp of having Einstein GPT, and it looks like it's going to have some really nice test generation capabilities, including trying to implement test logic. I may look and see how that works before I decide if generating stubs is even useful or not. Could be that just kind of obviates the need for test class and stub test method generation. Okay, so having said all that, like I said, this was one of the most requested features, enhancements to Illuminated Cloud. So hopefully people are going to get this. They're going to love it. It's going to save them keystrokes, going to save them time. If you find any issues, let me know. Report it through the public issue tracker or email me at support@illuminatedcloud.com and let me know about them, ideally with the reproducible test case, so I can just reproduce it, fix it, and then release that fix. If you can think of other things that you'd like to see happen, things that would save you time through this kind of code generation capability, let me know about them. Otherwise, I hope you find this to be really useful, and I hope you stay well. Thank you very much for your time. Take care. Bye.